We're going to take notes on orbital motion and inertia. Turn to page 32. It's important to know that gravity has to deal with inertia and orbital motion. Now, if you look at this picture right here, here's our Earth, here's our moon. These white bulges right here are our ocean waters, kind of showing tides. Now, I just wanted to point out these little white lines right here show that the Earth and the moon are pulling on each other. Remember that gravity is a force of attraction, so things are attracted to each other. So it's important to know that the Earth, Sun, and Moon are constantly pulling on each other. Well, that's nice, but if they're constantly pulling on each other, wouldn't the Moon just pull right into the Earth? That's where this thing called inertia comes in. So inertia is the tendency of an object to resist a change in motion. Now, below is an example. So here's our lovely bus right here. And in our bus driver right here stops short. If you notice, all of the people, when the bus stops short, want to just keep going in this direction. Because although the bus stops short, their body's still moving in that direction. And they keep wanting to go in that particular direction. The sumo wrestler. Quite possibly my favorite example when it comes to this particular topic. I say this because you could use the sumo wrestler to talk about mass. You could use the sumo wrestler to talk about weight. You can use him to talk about gravity. And in this case, we're going to use him to talk about inertia. Now, inertia is the tendency of an object to resist a change in motion. Right now, this big guy and this little guy aren't moving, so they're at rest. Inertia says they're going to try to resist it. Well, they can, but when you think about it, when they are going to start to move, who's going to move faster? This big guy right here or this little guy right here? If you said the little guy right here, you're correct, because he has he has a lot less mass than this guy. Now the problem is, this guy has so much mass that once he gets started, it is going to be very difficult to get him to actually stop. So that mass is going to take him to keep going and going and going till finally, he'll finally stop. It's important to know, even though they're at rest here, they're going to stay at rest until they resist that change in motion. Once they become in motion, it's going to be very, very difficult for them to stop. And we notice that this guy right here, it's hard for him to stop while he's moving, and it's hard for him to actually get going as well. So like we discussed before, the more mass an object has, the greater the inertia, and the harder it is for it to stop moving or start moving. If you think about a garbage truck and you pull up next to it, it's very difficult for that garbage truck to actually start moving faster before you. So that's kind of showing inertia because it's resisting that change to actually move. Now the second part over here, again, Newton was that guy. Newton kind of discovered everything at one point in time, it seemed like. And he was the first to realize inertia and that it exists. And because of that, he was able to name a law after himself. Now, you'll soon realize that Newton has several laws named after himself. But this one is Newton's first law. Of motion. And that again says an object at rest stays at rest, and an object in motion will stay in motion until a force is acted upon it. Now, if you think about the force that's acted upon this guy right here to actually have it stop moving, well, there's gravity if he does fall, and there's one that we kind of talked about briefly in our WWK, which is friction. Because as his feet's rubbing against the floor, it kind of has him stop as well. Two things that we've spoke about already has been gravity and inertia. These two things are very important because when these two things combine together, they help us give us the circular pattern in which our moon, our Earth, our other planets follow. So if you look extremely closely at this picture, here's a picture of our moon right here. Our moon is being pulled towards the Earth. Our moon wants to be pulled towards our Earth at all times. Well, it's not pulled directly on our surface because of inertia, because our moon wants to keep moving in a straight path. Well, we don't have a straight path because we're getting a pull. So it's kind of like we're being pulled straight, but as we're being pulled straight, gravity is pulling us closer towards the Earth. Same thing for us if we're the Earth. We're doing the same exact thing as we go around the sun. We might want to go this way, but we can't because the sun is pulling us towards it. So we're forming an elliptical shape rather than floating off into space. So what we know for the first blank is that inertia explains why our Earth stays in motion. So it stays in motion because of inertia. It does not want to resist that change. But it creates that elliptical pattern because of gravity. Is pulling on that Earth. These two things combine to allow for orbital motion to take place. Very difficult to understand why this orbital motion happens. But if you remember that the two main important parts, inertia and gravity, combine to allow that orbit, elliptical shape, in some cases circular shape, to happen, then you should be okay.